Excellent. Okay. So this talk is based on a paper that John Webb and I published earlier this year on Australia's longest coastal cliffs and how big they are and why they are, the way they are. And these are the cliffs that we were talking about. Pardon me, I'm just going to move a thing out of the way here. Okay. So this arises from a geoheritage study that Sue White and I did a large number of years ago now, where we were commissioned by the government to do a geoheritage assessment of, all of Australia's arid lands. So like, not a big ask at all. And one of the things that we kept coming up with was that people kept mentioning two coastal cliffs in particular, and they are the Zuidorf Cliffs here in West Australia and the Bunda Cliffs here in South Australia. People are very proud of them. They talk about them a lot. Some of the things that we saw mentioned a lot in the community media tended to be along the lines of, amongst the longest coastal cliffs or the biggest cliff or whatever. So people talked about the sheer drop to the ocean, and the cliff line continuity was a really big topic that kept coming up again and again. This was things that we saw particularly in community tourism media. So it's clear that these things are valued in the community. Now, the concept of something being the longest in Australia is, may not sound of very great scientific moment, but it's hooks like these that the geotourism of these remote areas hangs on. So, these are important facts to get right, because these are important to the local communities. And what we started to find was that although these areas were really strongly valued, people had no idea really what they were, where they were, or how big they were. So there's a table in the paper that goes into more detail. But for example, the Zuidorp Cliffs were discussed as being, more than 200 kilometres or 150 kilometres long, or the longest fault scarp in Australia, which was kind of surprising. Similarly, the Bunda Cliffs in South Australia were variously mentioned as being 209, 800, 100 kilometres long, and referred to as the longest stretch of coastal cliffs in the world. Again, clearly there's some issues here with both measurement and nomenclature. One of the big issues was that the people were talking about these cliffs down here at the bottom edge of the Nullarbor Plain, and they'd be mixing up the Bunda Cliffs with the Baxter Cliffs, which are over here. So the questions that this study started with are two really simple questions, which are, which is the longest of these two coastal cliffs, the Bunda or the Zuidorf? And in order to measure the things and get the answer to that, first we had to develop some clarity around the nomenclature of the Nullarbor Plains cliffs. For anybody who likes reading the last chapter of the book first, you'll see down the bottom of this slide is the answers that we came up with. We'll come back to those at the end of the talk. So here is a digital elevation model of the two study areas as they are on the Australian continent. Here, the Bunda and Baxter Cliffs along the southern edge of the Nullarbor Plain in the Eucla Basin, and here the Zuidorf Cliffs near Shark Bay. This data set is the shuttle topography radar mission 3-second data set, grafted onto the Geoscience Australia bathymetric 9-second data set. So all these colours that you see around the edge of the DEM represent true underwater topography. First, let's have a look at the Zuidorf cliffs. There are, the dotted line is the extent of the cliff line, and there are two parts to the Zuidorf cliffs. Excuse me. The Edelland Peninsula up here in the north, this is the bit that's closest to Shark Bay, and the geography here is Steep Point at the end, false entrance, that little nick there. And then the southern part of the cliffs is backed down here by this limestone ridge, which is the Tamala Ridge. Down here is the town of Kalbarri. In the middle here is a transition area, which is discussed in the reference Playford et al. From the West Australian Geological Survey, where he goes into a lot of detail about the significance of this transition area for the evolution of this landscape as a whole. I'll ask you to note the different backcliff topography of these two areas. It's dune crests behind here, and behind here it's this big ridge line. This is what it looks like in the Google Earth, with the ridge line here, and you can see the cliff top, the dune crests, and obviously the more you zoom in, the better you see them. To summarise the geology of the Zuidorf cliffs, they are formed, the rock that the cliffs are cut into is a porous bioclastic calcarenite. It had an aeolian environment of deposition, thus the back cliff dune topography. There was the regional uplift that brought the cliff line up as a whole, and there's also some local structure, which is the Zuidorf Fault, which has had at least a 3-stage uplift discussed in Playford et al. Now, the thing that I know a number of you are here because of your connection with, the Nullarbor Plain, which is the onshore part of the Eucla Basin. The bulk of the Nullarbor Plain, or the onshore part of the Nullarbor Plain, is the Bunda Plateau, and the southern edge of this Bunda Plateau is a really long scarp line. And this is the nomenclature of the scarp line as we could identify it according to, there are various regulatory bodies that govern how you name landscapes. I mean, it's a bit like stratigraphic nomenclature. You can't just whack any old name on there. You have to, look at the rules. So the Bunda Cliffs, which in the past has also been known as the Nullarbor Cliffs, thus the confusion, because both the Bunda Plateau and the Nullarbor Plain are obviously a much bigger feature than these cliffs. The Bunda Cliffs, which face out into the ocean. The Hampton Range, which faces out, it's a scarp that faces out across the Roe Plain. Then the Baxter Cliffs, which again faces out into the Great Australian Bight. And down here, the Wiley Scarp, which faces over the Israelite Plain. Surprisingly, for a feature that is so big, this entire long, in black here, cliff line did not previously have a name of its own. So in this paper, we have named it the Great Southern Scarp. It's a huge, significant landscape feature. It really ought to have a name of its own. A summary of the geology of the Great Southern Scarp is that it also is a porous bioclastic calcarenite. It has a different environment of deposition, so it was laid down in a marine plain, and thus the back cliff area is the famous amount of flatness that the Nullarbor Plains is. It's a vast karstic plain which has experienced downwearing and formation of Jura crust, but it kind of started out flat and then kept being flat. It's experienced regional uplift, and it's had some local structure, so more but smaller and later uplift, which has created the marine plains. So the broad uplift that has brought this whole thing up out of the ocean, and then later and smaller uplift giving you that and that. Okay, yeah, so that's the Great Southern Scarp. Now, the measurement. See, I didn't think this was going to be very difficult. You know, Google Earth measuring tool, how hard could it be? As it turns out, it's harder than you'd think. So the first thing that needed to happen was defining the cliff line, and I used the digital elevation model with, here's the DEM of the top-down view of the Roe Plain and the Bunda Plateau section of the Nullarbor, and then taking perpendicular cross sections and looking at the DEM to make sure that the cliff face was identifiable. Also on the Google Earth, using geomorphology clues to make sure that the cliff line was identifiable. So it's surprising how much information you can get on a remote study like this. So for example, in this view here, you can see the texture of this area is quite even because it's a flat soil surface, and then as you go over the sharp edge of the cliff, it becomes rough and hackly, and you can see the exposed layering of the rocks. Things like the degree of verticality of the Google Earth view. So as you move past it in Google Earth, you can see, you can have a sort of a rough and ready measurement of how steep the cliff line is by how much of that vertical face is exposed to a top-down view. There are also cultural clues. So for example, you'll see here is a fence line which stops at the edge of the cliff. Pretty clearly, it's too steep to go down there. So clues like this that allowed a definite cliff line to be established, and then that could be propagated onto basically propagated backwards and forwards between the Google Earth view and the DEM to enable the measurement to take place. It's obviously pretty clear here where is the cliff line, but in some of the other places, like on the Scarp overlooking Roe Plain and Israelite Plain, it was the Scarp is more gradual, so it needed a bit more, you know, work and interpretation. Now, if you're going to do a numerical measurement, ideally you want to identify your error term, your confidence level, how many plus or minus horizontal meters is there going to be in this measurement. For anybody who's done a lot of work using Google Earth, you'll know that it was actually it's actually quite difficult to establish that, because even for a Google Earth each individual image, it's sometimes not clear when the image was taken. The degree of accuracy of the georeferencing varies from image to image. So long story short, in a study this size, it was actually not possible to establish the confidence level of each measurement as it was taken. However, that didn't really turn out to matter, because the biggest issue of doing this kind of measurement is what's known as the coastline paradox, which is that the measurement result depends on the level of detail. This is to do with chaos theory and fractals in geomorphology. But basically, with this classic picture of the coastline of the UK, if you measure in big jumps, you get a different number than if you measure in increasingly more detailed segments. So if you're going to do a numerical measurement of something like coastline length, you require a defined scale of measurement. The measurement on its own is not meaningful unless you've actually defined your methodology. And then if you're going to do two comparisons, like trying to figure out whether the Bunda cliffs are bigger than the Zoidorf cliffs, both of those measurements have to take place with the consistent method. So taking the various factors into consideration, the best balance between precision and actual reality was to round the cliff lengths to the nearest kilometres. And the happy result is that the Zoidorf Cliffs and the Bunda Cliffs are both 210 kilometres long. So both of these are Australia's longest coastal cliff. That means that both South Australia and West Australia can claim Australia's longest coastal cliff. So that's, you know, that's good news. However, there is more to the story with the Bunda Cliffs. So the Bunda Cliffs are part of the Great Southern Scarp, which measures as 820 kilometres of continuous cliff line and scarp line. It consists of two coastal cliffs, which are the Bunda and the Baxter. So the Bunda's in South Australia, the Baxter in West Australia. And two paleocoastal cliffs, which are the Hampton Range and the Wiley Scarp. At this point, one wonders, why exactly are they cliffs? This is quite a lot of cliffiness happening around our coastline. What's the backstory here? So the first thing about the cliffs is Australia's post-Miocene continental tilt, and this is the work that many of you will know from Mike Sanderford and his colleagues. Basically, Australia's been going around lumps in the geoid, and the northeast part of the continent has been going kind of head down, and the southeast has been going bum up, and so we've got cliffs here, and it's all very cliffy. Because of the uplift, the rock has been exposed to the wave attack, and particularly in the Southern Ocean, that's quite vigorous wave attack. Porous and variably cemented bioclastic calcarenite. For those of you who are red hot on thin section work in carbonates, please note that the micrograph I've got here is not actually one of the Nullarbor lithologies. It was something I got off the web, but the point is that it's got all these little fossily bits in it and a lot of pore space in it. So this lithology is strong enough to maintain a vertical cliff face, but weak enough to be sapped at the base when it experiences wave attack. So this leads to the conditions that are ideal for cliff face retreat. Excuse me. But this lithology is actually notoriously widespread. Like this, Eocene to present temperate carbonate sediments extend all the way along the coast. So all the green stuff here is the same bioclastic carbonate that goes pretty much all the way around. So why is it that only the Zoidorf Cliffs and the Great Southern Scarp are famed for their degree of cliffline continuity? Doing a comparison between the disposition of these bioclastic carbonates and Australian coastal cliffs, doing a very rough measurement of two data sets, you can see that the lithologies definitely a strong contributor, because there's a good correlation between the places in pink where there are coastal cliffs and where this carbonate lithology is exposed at the coastline. But only the Great Southern Scarp and the Zoidorf are famous for the cliff continuity. So what's the deal? Here we are in Australia's Otway Coast, which is also famous for its beautifully scenic cliffs. But in the case of the Otway, we've got a whole lot of jointing, which promotes differential scarp retreat. So the water gets entry along the joints, and that allows weathering to take place. And so you get these beautiful crenulated coastlines, beautiful in their own way, but not the beautiful continuous thing that we see along the Great Southern Scarp. So when you don't have any jointing, you have the conditions which are right for uniform scarp retreat. But the other really big feature is the aridity. The cliff lines are preserved by the lack of drainage. So the Great Southern Scarp and the Zuidorf are the cliff lines which are in the arid areas. So there is less local rainfall to sculpt into the cliff line. In the Nullarbor Plain, what surface drainage there is can be captured by dolines and ushered out into the Southern Ocean via the cave systems. So here's Nick White showing us some of the dolines on the Nullarbor. And then there's the topography, which isolates the cliff lines from any drainage that's developed elsewhere. So in the Nullarbor Plain, you can see that there's very long lengths between drainage that develops elsewhere in non-karstic country. Here's a paleo drainage line coming in here, but it's got this many kilometres to cover before it actually reaches the scarp line, and it's just never going to make it because there's all these dolines in the way. And in the Zuidorf Cliffs, you've got the Tamala Ridge forming a coastline parallel drainage divide really close to the coast. So the only drainage that comes along here is from rain which falls immediately on the ridge. And here you've got the topography dominated by the dune field, or the paleo dune field in the background. So the cliff lines are preserved by the lack of drainage. So in summary, the conditions that create these extremely long coastal cliffs are, you have regionally uniform scarp retreat rates. You have broad, the scarp retreat rate is promoted by the broad spatial scale of the homogeneous and undeformed calcarenites. You have an equally broad scale regional uplift that brings the rocks to face wave attack. And then you have the cliff works that are undissected by fluvial networks because of their topography, their aridity, and their development of karst features. So if you were to be looking somewhere for a regional, for a very long continuous cliff line, coastal cliff line, you'd be looking for a place that had extensive and lithologically more or less uniform calcarenite in an arid karst setting along the coastline of a continent experiencing regional uplift. At this point, starting to wonder whether this is actually rare on a world scale. Arid coastal carbonates occur in places. This is the Williams and Fong carbonate data set. And there are certainly some carbonates along the coast and even along the arid coast. But I think one of the other things is that Australia's continent is more free to express itself in the sort of continental movement that allows an entire, half the continent to tilt itself up. At this point, when I was thinking about these questions, I was envisaging the rest of the world as being, constrained against their neighbours and locked down in a way that didn't allow them any freedom of movement. Whereas Australia was kind of the flower child hippie of the continents and gets to dance around as much as it likes. I've since had discussions with people whose research area is continental tectonics, and that's probably a gross oversimplification. Still, in summary, this paper presents a repeatable and explicit methodology for measuring our coastal cliffs. In Australia, our longest coastal cliffs are the Zuidorf and the Bunda, equally at 210 kilometres. Australia's longest continuous intact cliff line is the Great Southern Scarp at 820 kilometres, and it's extremely unusual in that it contains both coastal and paleocoastal cliffs, and we suggest that it is probably rare on a world scale. that's the end. And if anybody wants to screen capture those references, if they want to chase up any of those data sets, there it is. Thanks very much.
Great. Thanks very much for that. That was very interesting. And we've now got time for some questions and answers, hopefully. So are there any questions out there?
I've stunned everybody into silence.
Well, it's more
I've
everyone working out how to unmute and everything. So Brendan, you've got a question?
Yeah. So I just had a comment. Or kind of question as well. But regarding the scarps that intersect the cliffs, do you see a wavelength of change in cliff height, in coastal cliff height, on the uplifted side of the scarp? Any idea what that wavelength of uplift is? So like
I just got hit by a massive echo. Which one's the Zoidorp or the Great Southern Scarp?
So whether at is it Madura, the scarp that intersects the coastal cliffs at Madura, do you see because I mean that scarp is fairly high, you know, in the order of, you know, certainly in the order of 20 meters plus. Do you see a wavelength over which that uplift is focused, like changes the height of the coastal cliffs, or is that sort of unconstrained?
Look, I didn't have the opportunity to measure heights in detail along the length of the study, partly because it's such a long study, also because the SRTM data, although it's amazing data to work with and I love it to death, its vertical accuracy is not great. So it would have been misleading of me to engage in any detailed exploration of the question of behind the Roe Plain is discussed in fairly great detail in, I haven't got that reference listed on my last slide. Is it James et al? Cast Nullarbor people, help me out here. James et al. Discusses the geology of the Roe Plain in a paper that was in AJES some time ago.
Okay, cool, thank you.
Thanks very much. And there is one on the chat, Gresley. Do you have a feel for the rate of cliff retreat for the Bunda Cliffs?
Andrew Short, who's the coastal geomorphologist professor at Sydney University, had sent me an email where he said, I think it was some tens of centimetres a year. I can't remember the detail on that, partly because it's quite variable along the lengths of the cliffs, but it's certainly quite rapid. Where the cliffs are exposed to the Southern Ocean, you can see the freshness of the cliff face is expressed in the geomorphology. And if you look at the cultural features, you can see, you know, places where people used to either walk or drive to the cliff line and where they really don't want to be doing that anymore. But look, I feel like Steve Milner perhaps, or one of the other Nullarbor people might have a better feeling for cliff retreat.
Actually, it's my question, Gresley. I have a sense that it's very fast in places, you know, because 10 meters can drop off, and sometimes, you know, 40,000 tons can drop off very, very suddenly. but there are areas of fresh exposure of cliff, which we can see from aerial photos to see that the cliffs are actually actively undermined. So all of the undermining happens quite a lot, I think, and then all of a sudden the top drops. But the rate, you know, I was told that the coastline was, you know, sort of like tens of kilometers further out in the last glacial maximum. But I don't have access to the knowledge for that.
I think there's also, you know, from the point of view of who's using the information and what they want the information for, I think that there's a difference between the average rate of cliffline retreat, which would be a kind of a scientific question about, you know, how the landscape is evolving, as opposed to the questions that might occupy the minds of people who are working in the Nullarbor cliffs, and particularly yourself working on the scarp, where my understanding is that the cliff retreat will be non-uniform across the face of the scarp, because when rocks, you know, when there's a cliff fall, then the base of that cliff is protected for a while by the rocks which are at the base of the cliff. So if you're looking at a place where you can see a bunch of rocks at the base of the cliffs, maybe that bit of cliff line will be stable for a while, whereas a section further along that doesn't have any rubble left at the base of the cliffs may be vulnerable to a more sudden dropping off. But I haven't got any measured numerical data myself that I know of.
I was particularly interested from an anthropological perspective. It's one of our objectives to potentially find caves in the cliffs exposed by the cliff retreat, which may have once housed artifacts and things like that. So getting an understanding of the rate of cliff retreats is really, over the last 10, 20,000 years, it's a really interesting question, so that we can target where we look.
I would imagine for those here present who actually have, you know, funding for honours projects and postgraduate minions and stuff like that, I would imagine that it would be possible to use drone data acquisition to map the amounts of rubble along the cliff base and get a rough feeling for the relative ages of the different cliff faces. But I don't know, you know, how feasible that is, but I think it would be an interesting line of inquiry.
Yeah, thank you.
Hello?
Hey, Nick, we can hear you.
Yeah, Steve, archaeology for the Nullarbor has really only been done in Cunalda Cave. You have 4 provable walk-down areas which access, let us say, the seashore and the flint nodules down at the base of the sequence. Do you have a perception of their age, or whether there was 10 walk down areas in the past and now there's only 4?
Okay, yes, I do have a good feel for that. So at the western end of the Bunda Cliff and at the eastern end of the Bunda Cliff, at the head of the bight, there are stone lakes, evidence of stone tool making at both ends, but it's hard to actually date those. But I'd say at the Wilson Bluff end, it looks quite stable, whereas there are in the last couple of hundred years, there are supposedly 3 walk downs in between Wilson Bluff and Head of Bight, and only one of those is actually accessible these days. So 2 have disappeared, safely. So Aboriginal people many years ago might have been a lot braver in going down the cliffs and without ropes and things like that than we are today. But there are certainly 2 or 3 or even 4 potentials which are really hairy walk downs. But yeah, except for the western end and eastern end, we haven't seen any archaeological evidence.
Great, thank you. So are there any other questions? If there's no other questions, I'd just like to thank Gresley for a very interesting talk, and thanks everyone for joining us today. I'm not the host, so I'll hand back to Michelle or Tim. Thanks very much, everyone.
Oh, I just noticed that Neil Phillips had his hand raised.
Oh yes, okay. Well, let's take that one.
And David Moore too.
Rightio.
Neil first, and then David.
Neil Phillips here. Gresley, nice talk. Thank you very much. I enjoyed that a lot.
My pleasure.
My question starts with heritage, and that's what really got you and Sue White into this, and not meant facetiously. What is there worth preserving in these cliff lines? And by that I mean, what's at risk? Because they seem to be the type of thing that aren't going to be damaged except by nature plucking bits off here and there. What should we be preserving because they're heritage value?
Specifically regarding the geomorphological heritage, so I want to be really clear here. I am not referring to cultural heritage, and I'm not referring to biological heritage. So just with reference to the geomorphology, the things that both the Great Southern Scarp and the Zoidorp contribute to the nation's heritage are, I think, things that are pretty robust. So the length of the cliff lines and the way that they represent some very important and broad scale things about Australia's landscape evolution is not something that people are going to be able to damage too much, I don't think. There are some of the in the paper, it goes into a little bit of detail about the potential kinds of geoheritage. So at a slightly lesser level of significance, the state level of significance, there are some things that maybe would be more vulnerable to poor land management or whatever. But the things that are a national or international scale of significance, as far as the cliff length goes, I don't know that there's anything we could do to damage that. I don't think I'm missing anything.
No, thank you. That does answer my question. My question was about the geomorphology. So,
yeah.
Thank you.
Thanks very much. And David?
Yeah, I just wanted to thank Gresley for a great talk. I got the wrong signal up on my thing, but definitely a thumbs up. Thank you very much.
Certainly, my pleasure.
Right. Thanks very much, David. I'll just scroll and have a look. There's no more hands. Neil's got an old hand up. So yes, thanks very much, everyone. And I'll hand back to Tim or Michelle to wrap it up.
Thanks, everybody. I won't hold you up, but just wanted to say I think this format works really well at lunchtime. So hopefully all of you like having lunchtime talks as well as afternoon ones. We'll continue to, as David mentioned before, we'll continue to mix it up a bit to give the chance for more audiences to join us. If you're thinking about wanting to present, you can see also now that we can expand our audience to other states and even international. This was an open presentation today, and so if you have an audience that you haven't been able to reach within Melbourne that you are keen on doing, please think of us as an opportunity to present through. A lot of these talks, Tim can let us know too. He's also been promoting them within our social media, so things like our Facebook accounts and that sort of thing. We've got massive audiences for now. Our Instagram account has about 30,000 people, so which is enormous. So if you have stories to share or photos of geological sites around Victoria that you'd like the rest of Australia and the world to know about, please consider sending them to Tim, because he's doing an amazing